Hi, in this video, you will learn how to wire a room in the home that has receptacle installed as required and a recessed lighting controlled by a single pole switch. After watching this video and understanding the topics covered in this video, you will be able to wire such a room yourself if you have some manual skills. This video will take you from the scratch to completing the electrical installation in such a room. Wiring is also described in great detail and supported by articles from the latest edition of the National Electrical Code. Example of a room wiring according to the NEC with a recessed lighting controlled by a single pole switch. As an example of a habitable room is a medium-sized room, 15 feet by 12 feet, with 2 windows, hinged entrance door and a storage closet, 2 feet by 8 feet, total, 196 square feet. It is a brand new room or completely gutted. An electrical plan will be drawn for this room. Symbols commonly used on electrical plans that need to be known to draw a plan for the room. Duplex receptacle. Switch-controlled receptacle. Surface mount light outlet. Recessed light outlet. Ceiling fan. Ceiling fan with light. Single pole switch. 2023 NEC, National Electrical Code, requirements for such room. As per Article 210.52 of the 2023 NEC, receptacle outlets are required to be installed in this room and located in the locations specified in this article. In addition, Article 210.70, A.1, requires the installation of at least one lighting outlet, controlled by a wall switch located near the entrance to the room. For this room, an exception in the Article 210.70, A.1 also allows the receptacle to be controlled by a switch, instead of installing a light outlet. According to 2023 NEC Article 210.52, general purpose receptacle in the habitable rooms, excluding specific rooms defined by NEC, must be located as follows. There is no point on the wall more than 6 feet from the receptacle, measured horizontally along the floor line. Any wall space 2 feet or wider must have a receptacle. Receptacle installed in the floor or on the floor can be considered as a receptacle required if it is installed within 18 inches of the wall. Receptacle required by NEC for habitable rooms cannot be installed higher than 5.5 feet above the floor level. The switch must be installed so that its handle in the up position is no higher than 6 feet 7 inches from the floor, in accordance with Article 404.8, A, of the NEC 2023. The NEC does not specify the location of a light outlet or the number of lumens a light must provide in a given room in a home, but local regulations may require lumens per square foot in some areas for safety reasons. An electrical plan prepared for the room to be wired that meets the 2023 NEC requirements. How to select a branch circuit for this room. Article 220.41 of the 2023 NEC states that the minimum load in a dwelling unit, house, shall not be less than 3 volt amperes per square foot of exterior floor area, excluding porches and areas that will not be used for habitable purposes in the future, which includes all receptacles rated 20 amps or less, lighting outlets and motors up to 1/4 horsepower connected to the lighting circuits. If a load of 3 volts amperes per square foot must be calculated for the floor area described in Article 220.41 of the 2023 NEC for general lighting in a home, the total area to be wired is only 15 feet by 12 feet plus a storage area of 2 feet by 8 feet, for a total of 196 square feet. According to NEC, Calculating the load per square foot, this area requires 196 square feet times 3 volt amperes equals 588 volt amperes general lighting load. When divided by the supply voltage, 588 volt amperes divided by 120 volt, the current is 4.9 amps. As per Article 210.23b of the 2023 NEC, a lighting branch circuit can be 15 or 20 amps and may be used to supply lighting outlets, receptacles, and utilization equipment, or a combination thereof, except receptacles located in specific locations such as laundry rooms, bathrooms, etc. When the load for this room is determined by the general lighting load calculation and the volt amperes power required for that room, we only need a fraction of the 15 or 20 amps branch circuit current as calculated. 4.9 amps divided by 15 amps equals 0.33% of the 15 amps branch circuit ampacity, and 4.9 amps divided by 20 amps equals 0.26% of the 20 amps branch circuit ampacity. So if the room load is unknown, a new 15 amps circuit will be perfectly sufficient, or you can draw power to that room from an existing branch of the house lighting circuits, as the load used in that room may be even lower than the calculations suggest. This is theoretical because even if the room is not wired, it still needs to be included as a future habitable space in the calculation of the general lighting load for the house per square foot, and if it is a new habitable space added, other electrical outlets already existing in the house can cover this space. The 180 volt amperes per square foot receptacle load calculation specified in 2023 NEC Article 220.14 I does not apply for dwelling unit load calculations. In reality, the general lighting branch circuit must be calculated based on the load to be connected to the lighting branch circuit supplying the room. The NEC does not specify the number of outlets in a general lighting circuit. The number can be virtually unlimited, but good wiring practices recommend 10 to 15 outlets. The number of outlets should be selected depending on the load, because in some rooms, like the bedrooms, the load is low, while in others, such as living room, it may be higher. When selecting a branch circuit, it should also be considered that the cord-connected equipment to a branch circuit cannot be rated greater than 80% of the circuit rating per 2023 NEC Article 210.23b(1). And the continuous load connected to the branch circuit also cannot exceed 80% of circuit ampacity. Although a branch circuit may be 15 or 20 amps, in rooms such as a home office, bedrooms, living rooms, etc., and all the light outlets in the home, the optimal choice is to use a 15 amps branch circuit with 14 gauge wires for these installations. 14 gauge conductors are the smallest wires allowed for branch circuits in homes per 2023 NEC Article 310.3. Cables commonly used in homes with 14 gauge conductors, wires, are most flexible. Junction boxes can accommodate more wires. Wires are easier to be spliced or connected, and cables are less expensive. In a room such as a home office or similar, one 15 amps branch circuit is sufficient to power lighting and equipment plugged into the receptacles. If the circuit is used solely for lighting, the number of connected luminaires, light fixtures, should be calculated based on their ratings, and consideration should be given to whether the load should be considered continuous under the load definition in Article 100 of the 2023 NEC. Typically, general lighting branch circuits in homes are wired with 14 gauge conductors. For house wiring, the most popular cables are NM, non-metallic sheathed cables with copper conductors of the various size and ampacity required to wire a specific area or appliance. All requirements for NM cable installation are specified in Article 334 of the 2023 NEC. A drawn plan of the electrical installation, on which recessed lighting outlets will be installed in the room in place of the central lighting outlet. The wiring for this home office or a similar room will be done using 14-gauge NM cable. Materials needed to install wiring in the above-mentioned habitable space, home office. For rough-in wiring will be needed 14. 2 NM cable. Receptacle, switch junction box. Wire nuts. Staples. Recessed light housing, if this type of recessed light will be installed. Nail plates. Cable stackers. And the bracket for canless lights may also be needed, depending on the installation. To complete wiring will be needed duplex receptacles, single pole switch, switch and receptacles wall plates, AFCI, arc fault circuit interrupter, circuit breaker, button type cable connector. Box extender may be needed. Recessed light trim listed for the light fixture housing already installed. Or canless recessed light fixture, depending on the type of installation. Measurement and marking of the room for installation of the electrical devices. Receptacle placement in the home office or similar room according to the 2023 NEC. And the drawn plan. The receptacles in this room must be placed as follows. No more than 6 feet from any openings in the wall, doors, fireplaces, etc. The distance between the receptacles cannot be greater than 12 feet. Any wall space 2 feet wide or more requires a receptacle outlet. The distance to and between receptacles must be measured along the wall line. To the center of the receptacle to meet the NEC requirement, no point measured horizontally is more than. At least one lighting outlet must be installed in a habitable room, controlled by a wall switch located near the entrance to the room. The NEC does not specify the location of a light outlet or its brightness, but other building and local codes may require this for a particular room. A single light outlet is usually located at the center of the room ceiling. Regarding the switch, the NEC only specifies the maximum height of the switch location, 6 feet 7 inches, and where it must be located, on the wall, but does not specify how far from the entrance to the room, near the entrance to the room, so other building and local codes and those having jurisdiction, inspectors, may require it. It is unacceptable to place the switch on the wall behind the door because this place does not meet the condition defined as near the entrance to the room. To locate and mark receptacle outlets on the walls, measure 6 feet along the wall from the opening, door, and mark on a stud or floor where the receptacle outlet will be placed along that distance. Repeat the same for the measurement from the other openings. Measure a distance of 12 feet from the already marked receptacle, and mark the location of the next receptacle in the same way, no further than 12 feet away. Repeat this step until all the receptacles along the walls are marked. If necessary, adjust the distances between receptacles and add more receptacle if needed. Measure small sections of walls, if any, and make sure they require a receptacle installation as required by the NEC. Wall requires a receptacle if it is 2 feet or wider. Measure the distance from the floor along the stud where the receptacle will be mounted, and mark the bottom of the receptacle junction box on this stud at the selected height. 14 inches is the most common distance from the floor to the bottom of the receptacle junction box. Repeat this step for each receptacle junction box in all locations. The most common distance is 14 inches from the floor to the bottom of the receptacle junction box, but this can be customized up to 5.5 feet. The entire receptacle must fit within this height, as permitted by the NEC. Marking the location where the switch will be installed. Measure the distance from the floor along the stud, where the switch will be mounted, and mark the bottom of the switch junction box on this stud at the selected height. 44 inches is the most common distance from the floor to the bottom of the switch junction box. 44 inches is the most common distance from the floor to the bottom of the switch junction box, but this can be customized up to 6 feet 7 inches as permitted by the NEC. Switch handle in the up position cannot be higher than 6 feet 7 inches from the floor. A non-metallic, nail-on Carlin 22.5 cubic inches junction box was selected for the receptacle outlets and switch. Details of the Carlin, non-metallic, single-gang, nail-on junction box. This junction box is accepting only NM, non-metallic sheathed cables up to 10 gauge, and can be mounted to wooden material only. This junction box 22.5 cubic inches requires a wall at least 3 inches deep. Similar junction boxes with less capacity with shallower depth are also available. Front view of a single-gang Carlin junction box. Box size volume in cubic inches 22.5 cubic inches. As per the exception specified in Article 314.17. 2 of the 2023 NEC. The cable entering this type of junction box must be secured to a stud within 8 inches of the cable entering the cable knockouts because these knockouts do not have any cable clamps. Multiple cable entry through the same knockout is also allowed. The maximum number and size of wires that can fit in a box for ease of calculation. Each insulated wire counts as 1. All uninsulated bare wires counts as 1 up to 4 conductors based on the largest 1 volume of the wire plus 1/4 volume of each additional conductor. Each device, receptacle, switch, etc. counts as 2 based on largest volume of the conductor inside the junction box as per Article 314.16, b. 1, 4, 5. Of the 2023 NEC. Example of a simple calculation. The number 11/14 on the box means that the junction box can accommodate 11 of 14 gauge, American wire gauge, wires. Calculation for 414, 2 NM cables. 4 white and 4 black wires, as 1 each, 4 plus 4 equals 8. 4 bare ground wires as 1 device, receptacle, switch, etc., to be installed as 2. Total, 8 plus 1 plus 2 equals 11. It means that the junction box can accommodate a maximum of 414, 2 NM cables and 1 device. The above calculation shown is simple for same gauge wire size. Calculations when there are mixed conductors, wires, inside a box are more complicated and can be made by calculating the value required for each conductor according to Table 314.16, b. 1, or, more easily, by calculating the number of conductors using the number of conductors allowed in that box and described for a largest wire size inside, for example, 10 wires of 12 gauge or 9 wires of 10 gauge. Knockouts for inserting the cables into the junction box. Nails for mounting the junction box to the wooden studs. Mounting holes for electrical devices. Side view of a single gang Carlin junction box. 1/2 inch distance stubs showing the junction box offset from the stud during installation to match standard house wall finishing. Drywall thickness 1/2 inch. Markings showing the offset of the junction box from the stud during installation for different wall finish thicknesses. Nail tips driven into the wood during installation. Top, or bottom, and rear view of the junction box. Nails at the top and bottom of the junction box in their guides. Installation of junction boxes. Once the entire room has been measured and marked, attach the junction boxes for the receptacles and switch to the studs. To install a nail on junction box, hold the junction box on the side of the stud and align the bottom of the box with a marking sign on the stud. Make sure the front of the junction box is far enough from the front of the stud to match the wall finish, usually 1/2 inch drywall. 1/2 inch distance stubs should evenly touch the front of the stud. While holding the junction box at side of the stud, drive the nails of the box into the stud. Junction boxes mounted to the studs. If necessary, add a piece of wood to move the junction box further away from any wall elements, door trim, wall corner, etc., to create enough space for the device wall plate installation. According to Article 314.17b of 2023 NEC, more than one cable can enter through the same junction box knockout. The cable must be secured no more than 8 inches from the cable entry point into the junction box, measured along the cable. And the cable sheath must extend at least 1/4 inch into the junction box. As per junction box calculations, this junction box can accommodate a maximum of 414, 2 cables and an electrical device, or 312, 2 cables and a device. Any other cable combination must be calculated based on the volume of the junction box. Vapor-tight junction boxes for external walls may be required to meet energy code requirements. Drilling holes for cables. The cables are run through structural wall members, studs, beams, etc., which must have opening in them to allow for their passage. In wood construction, cable holes can be drilled into structure wall members, but certain drilling rules must be followed as outlined in the NEC and other building and local codes. Holes for routing cables through wall studs can be drilled at any height in the center of the stud, on the wider side in the wall, but are generally located approximately 30 to 40 inches above the floor in each stud along the wall where they are needed. Side view of a 2 by 4 inches stud, wider side. The drilled hole should be no larger than 7/8 inch, standard drill bit size, can be smaller, but no smaller than 1/2 inch. The edge of the hole should be no closer than 1¼ inch from the edge of the stud. Drilled hole. Drilled 7/8" hole in the center of the 2x4 stud. 1/16" thick steel nail plate. If the edge of the hole is less than 1¼ inch from the edge of the stud, secure the cable in the hole with a 1/16 thick steel nail plate of the appropriate length. For holes greater than 7/8 inch in diameter, and if the edge of the hole is less than 1¼ inch from the edge of the stud, a steel nail plate must be used on both sides of the stud. Cable protected with a nail plate. If necessary, multiple holes can be drilled in the stud. A single stud can be drilled or bored to a width no greater than 60% of the stud width, and the hole should be no closer than 5/8 inch from the edge of the stud in non-load-bearing walls, and no greater than 40% of the stud width in load-bearing and exterior walls. Double studs in all walls can be drilled up to 60% of their width. If the edge of the hole is less than 1¼ inch from the edge of any stud, the cable must always be protected with a steel plate. In external or load-bearing walls, studs may have notches extending up to 25% of the stud width. And in non-load-bearing walls, studs may have notches extending up to 40% of the stud width. The cutout with the cable must be protected with a steel plate. The cutout must not be in the same place where the hole is drilled. When drilling the top and bottom wall plates, the same drilling rules apply as for studs. Hole were drilled in the top wall plate for cables. Holes in the ceiling beams, joists. In the ceiling beams, joists, holes may be drilled no larger than 1/3 of the beam, joist width, and at least 2 inches from the top and bottom of the joist to the edge of the hole. For multiple holes, the distance between the holes must be twice the diameter of the larger hole. The distance between these two holes must be twice the diameter of that larger hole. To drill a hole, maintain a distance of at least 6 inches from the end of the beam support point on its edges. For engineered beams, check the beam specifications for drilling holes in the beam. Holes drilled in the ceiling beams. When routing cables through metal studs, a snap-in sleeve must be used in each stud where the cable is installed. Requirements for cable installation in wood-framed buildings. All cables must be installed and supported in a neat and professional manner so as not to be damaged during normal building use, in accordance with Article 110.12 of the 2023 NEC. Cables installed and routed over beams, through studs and in horizontal grooves are usually naturally supported. NM cable, non-metallic sheathed cable, Romex cable, is described in the 2023 NEC, Article 334. As per Article 334.30 2023 NEC, non-metallic sheathed cable shall be supported and secured with staples, cable ties, straps, hangers or similar hardware and installed in such a way as not to damage the cable. Some approved, listed, materials for supporting NM cables: staples, cable stackers, cable ties. Requirements for the installation and support of NM, non-metallic sheathed cable. The NM cable entering the enclosure must be supported no more than 12 inches from the enclosure entrance. No more than 12 inches from the entrance into the enclosure, junction box. The distance between the supports shall not exceed 4.5 feet. No more than 4.5 feet between supports. The NM cable should be stapled on its flat surface, not on its edge. The NM cable should be stapled on its flat surface, not on its edge. The edge of a cable stapled to a stud, when the cable is run parallel to the stud, must be at least 1¼ inch from the edge of the stud in accordance with Article 300.4 d of 2023 NEC. Cables must not be stapled closer than 1¼ inch from the edge of the stud. If staples are used to support cables, they must be approved for supporting NM cables. Do not drive staples too hard into the cables. The staple should be driven in hard enough to hold the cable in place, but not too hard that it damages the cable. Driving the staple too hard can damage the cable. Do not drive a staple over an existing staple when adding and securing a second cable over the previously installed one. The staple must contact the cable with its flat surface, not its sharp edge. No more than 2 cables may be stapled together with the same staple. Although the NEC does not specify how many cables can be stapled together, almost all staples are designed to staple a maximum of 2 cables with one staple and must be used in accordance with Article 110.3 b of the 2023 NEC, which states that this should be done in accordance with the manufacturer's instructions. Do not damage the cable when removing the staple. If it is not possible to secure the cable with staples, too little space, a cable tie or other means of supporting the cable must be used as permitted by the NEC. If 1¼ inch distance from the edge of the stud to the edge of the cable cannot be maintained, use hangers, stackers, etc. to support the cable and pull the cables away from the stud. Also, when running multiple cables along a stud, use hangers, cable ties, or other means. A 7/8 inch diameter hole drilled in a 2 by 4 inches stud, actually 1.5 by 3.5 inches, for the cable works perfectly because it leaves a 1¼ inch margin on each side of the hole to the edge of the stud, so the cable running through this hole doesn't need a protection once installed. Since the NEC does not specify this in detail, in practice up to 3 NM cables, 14 gauge or mixed with 12 gauge, can be pulled through a 7/8 inch drilled hole. but the correction factors in Articles 334.80 and 210.15 c of the 2023 NEC regarding cable ampacity when grouped together must be taken into account. Approved 1/16-inch thick steel nail plate. The cable must be protected from physical damage and where there is a risk of nail penetration. The cable must be protected with a steel sleeve or plate at least 1/16 thick as per Article 300.4 of the 2023 NEC. According to Article 300.14 of the 2023 NEC, once a cable enters a junction box, the free wires exiting the cable must be at least 6 inches long and extend 3 inches beyond the junction box opening if the junction box opening is less than 8 inches in any dimension, so the cable entering the junction box must be long enough to be properly spliced. In practice, the cable should be between 12 and 18 inches long when entering the junction box so that it can be spliced easily and correctly. The cable sheath must extend no less than 1/4 inch beyond the junction box entrance or its cable clamp according to Article 314.17 b and Article 334.19 of the 2023 NEC. Class 2, Class 3 low-voltage cable and communication cable shall not occupy the same opening or raceway as a power cables, unless they are separated by a partition or are located within 2 inches of each other in accordance with Article 725.136 and Article 800.133 b. Installation of wiring in the home office or similar room. Cable routing. To make it easier to understand, the plan will be transformed and instead of the device symbols it will show the location of their junction boxes to clarify the installation of cables between these junction boxes. Room layout after conversion, showing location of junction boxes and light fixture housings, or light fixture location for canless light fixtures. As mentioned earlier, 2 nm cable will be used to wire this room because in a room such as a home office or similar room, one 15 amps branch circuit is sufficient to power the lighting and portable equipment. This 14-gauge, 2 nm wire in a 15 amps lighting branch circuit must be protected by a 15 amps overcurrent device, circuit breaker, and can have a maximum load of 15 amps per Article 210.24 and Table 210.24 I of the 2023 NEC. The 2 nm cable contains 3 conductors, wires. Bare wire, equipment grounding conductor, ground wire. White wire, grounded conductor, neutral wire. Black wire, ungrounded conductor, hot wire. Run the power supply cable from the electrical panel where the circuit will be connected to any of the installed junction boxes. In this example, the junction box where the branch circuit cable from the panel board will be installed is the junction box located near the door. When installing cables, keep in mind how many cables will fit in the chosen junction box. The junction box, Carlin 1 gang 22.5 cubic inches, chosen for the receptacles and switch installation in this room can accommodate a maximum of 2 nm cables and a device, as shown in the junction box fill calculation. The easiest way to connect junction boxes is to run a cable from one box to the other. Each junction box will have a maximum of 2 cables, daisy chain wiring. The 2 nm cable is installed from the panel board to the first receptacle junction box. To connect all junction boxes and light outlets in a daisy chain connection, run the cable as follows. from the junction box to which the circuit cable from the panel board has already been run. The same type of cable should be run to the next receptacle junction box, and to the next, and the next, and the next, and the next, and to the switch junction box, and to the first light fixture housing or light outlet location, and to the next, and the next, and to the last one. This is example 1 of how this room could be wired. All receptacle junction boxes have 2 cables. A cable from the power source and a cable to other electrical outlets that will be spliced, connected. The switch junction box have 2 cables. A cable from the power source and a cable to the light outlet that will be spliced. 3 light outlets, or housings, have 2 cables, a cable from the switch or light outlet and a cable to the other light outlet. 1 light outlet, or housing, have 1 cable, a cable from the light outlet. Cables between junction boxes and lighting outlets can also be installed in different ways. Once all cables are installed and inserted into the junction boxes, you will need to splice the wires inside these junction boxes to prepare them for rough-in inspection and for installing electrical devices once the finishing work is complete. The length of the cable entering the junction box should be between 12 and 18 inches to allow for easy and proper connection of the wires. The cable must be protected from physical damage where required. The cable sheath must extend no less than 1/4 inch beyond the junction box entrance. Cable splicing. Splicing is the joining, twisting together, 2 or more separate wires, conductors, inside a junction box. Splicing of the conductors must be made using devices identified for such use as per Article 110.14, b. 2023 NEC. The most commonly used splicing device for connecting wires is wire nuts. There are different types of wire nuts available. Wire nuts must be listed as per Article 110.3 of the 2023 NEC and are designed to connect a specific number of wires using a specific wire nut. Splicing ground wires using green wire nut. Separate the ground wires, bare, from the others and push the ground wires towards the back of the junction box. Twist the ground wires. Hold them in your fist. This will provide a minimum wire length of 6 inches, which is required by NEC, and cut the shorter wire at the front of your fist. Thread the long wire through the hole in the green wire nut and turn wire nut clockwise until it twists the wires and is no longer loose. Neatly fold and insert the wire connection into the junction box, leaving the pigtail wire outside the junction box. Any wire nut can be used to connect equipment grounding conductors, ground wires. But the green wire nut is specifically designed for connecting ground wires. The green wire nut can only be used to splice the equipment grounding conductors and is designed to splice bare ground wires. Non-metallic sheathed cables always have the bare equipment grounding conductors. This wire nut has a hole at one end through which one of the bare wires is pulled during connection, which then becomes a pigtail wire that is connected to the ground terminal of the electrical device or equipment. Wire nuts must be listed and used in accordance with manufacturer instructions as per Article 110.3 of the 2023 NEC. The green wire nut allows the connection of the minimum and maximum number of wires and wire combinations specified in the manufacturer specifications. For 14-gauge copper solid wires, this is typically 2 to 5 wires. Equipment grounding conductors must always be connected together to provide effective ground fault path for current as per Article 250.148/2023 NEC. The cut wires for splicing, excluding wire for the pigtail, must be at least 6 inches long from the point where they exit the cable sheath, and must also extend at least 3 inches beyond the junction box opening if the opening is 8 inches or less in any dimension, per Article 300.14/2023 NEC. The cable sheath must extend no less than 1/4 inch beyond the junction box entrance or its cable clamp according to Article 314.17b and Article 334.19 of the 2023 NEC. When splicing the wires, it is enough to make 3 to 5 twists of the wires, as too many twists can damage the wires. Pigtail wire emerging from green wire nuthole after connection. When it is necessary to splice more ground wires than can be connected with a single wire nut, use a larger wire nut, or separate the ground wires into parts and splice them separately. Then connect them together using wire jumpers between the connections. In addition, the pigtail grounding wire connected to an electrical device must be the same size as the grounding conductor of the circuit supplying this device. Splicing ground wires using standard wire nut. Separate the ground wires, bare, from the others and push the ground wires towards the back of the junction box to bend them. Hold the ground wires in your fist. This will provide a minimum wire length of 6 inches required by NEC, and cut them off at the front of your fist. Take a piece of bare wire for the pigtail and using pliers twist the wires together clockwise. Secure the connection with a wire nut. Neatly fold and insert the wire connection into the junction box, leaving the pigtail wire outside the junction box. A medium-sized universal wire nut that can be used for any connection for the number of wires specified in its specifications. The universal standard wire nut allows the connection of the minimum and maximum number of wires and wire combinations specified in the manufacturer specifications. For 14-gauge copper solid wires, this is typically 2 to 6 wires. When using a universal wire nut to splice ground wires, add the pigtail wire needed to connect the ground wires to the electrical device. The cut wires for splicing must be at least 6 inches long from the point where they exit the cable sheath, and must also extend at least 3 inches beyond the junction box opening if the opening is 8 inches or less in any dimension, per Article 300.14/2023 NEC. The cable sheath must extend no less than 1/4 inch beyond the junction box entrance or its cable clamp according to Article 314.17b and Article 334.19 of the 2023 NEC. The size of the pigtail wire must not be smaller than the size of the wires of the cables to be spliced. When grounding conductors of different circuits are spliced together in a junction box, the ground wire pigtail connecting the electrical device to the spliced grounding wires must be the same size or larger as the grounding conductor of the circuit to which this device will be connected. When splicing the wires, 3 to 5 twists are sufficient, as too many twists can damage the wires. A pigtail wire has been added to connect the ground wires to the electrical device. The ground wires can be spliced using a green wire nut, and one pigtail wire from this splicing can be connected to electrical devices in a daisy chain connection. Or the ground wires can be spliced with multiple pigtail wires using a standard wire nut, so that each device installed in a multi-gang junction box will be connected using an individual ground wire. A standard wire nut may also provide one pigtail wire that can be connected to electrical devices in a daisy chain connection. Splicing neutral and hot wires using wire nut. Separate the wires to be spliced from the other ones. Fold and push the wires towards the back of the junction box. Hold them, grab them and cut them in front of your fist. To make a pigtail, take a piece of the wire of the same size and color corresponding the wires that will be spliced. Strip about 1/2 inch the insulation from the end of this wire, as well as from the ends of the wires to be spliced coming out of the junction box. Using pliers and a wire nut, splice the pigtail and other wires together. Neatly fold and insert the wire connection into the junction box, leaving the pigtail wire outside the junction box. One of the medium-sized universal wire nut that can be used for any connection for the number of wires specified in its specifications. For 14-gauge copper solid wires, this is typically 2 to 6 wires. To splice the wires, strip approximately 1/2 inch of wire insulation from their ends. The cut wires for splicing must be at least 6 inches long from the point where they exit the cable sheath, and must also extend at least 3 inches beyond the junction box opening if the opening is 8 inches or less in any dimension, per Article 300.14/2023 NEC. The cable sheath must extend no less than 1/4 inch beyond the junction box entrance or its cable clamp according to Article 314.17b and Article 334.19 of the 2023 NEC. A better connection is achieved by twisting the ends of the wires with pliers and screwing a wire nut onto these twisted wires. Always twist the wires clockwise during splicing. The size of the pigtail wire must not be smaller than the size of the wires of the cables to be spliced. 3 to 5 twists of the wires when splicing are sufficient, as too many twists can damage the wire insulation. Never connect neutral wires of different circuits together unless they are from a multi-wire circuit sharing the same neutral wire. Neutral wires should only be connected together if they belong to the same circuit. Splicing the junction boxes for wiring the room. Cable run between the junction boxes in this example. Splicing the receptacle outlet junction box with the cable from the power source and the cable to the other electrical outlets, 2 cables. Cable from the power source. Cable to the other electrical outlets. All of these 2 cable junction boxes are spliced in the same way. 2 cable receptacle junction box. Cable from the power source. Cable to the other electrical outlets. NM cable must always be secured to the building structure within 12 inches of the cable entry into the junction box per 2023 NEC Article 334.30, but when the junction box does not have cable clamps, the cable must be secured within 8 inches of the cable entry into the junction box per the exception specified in Article 314.17, 2023 NEC. In addition, the NM cable sheath must extend no less than 1/4 inch beyond the junction box entry or cable clamp. Sketch of the wire splicing connection inside the junction box. When removing the cable sheath, leave at least 1/4 inch cable sheath length beyond the cable entry as required by NEC. Splice the ground wires using a wire nut, as the grounding conductors, wires, must always be connected together to provide effective ground fault path for current as per Article 250.148 2023 NEC. Trim all wires to 6 inches or longer, as wires must be at least 6 inches long from the point where they exit the cable sheath, and must also extend at least 3 inches beyond the junction box opening if the opening is 8 inches or less in any dimension, per Article 300.14 2023 NEC. Spliced, connected, wires inside the junction box. Open the selected cable knockouts in the junction box. Insert the installed cable into this knockouts and secure it no further than 8 inches from the junction box entrance, in accordance with NEC requirements for this type of junction box. Remove the cable sheath. The cable sheath should extend no less than 1/4 inch beyond the enclosure, junction box, entrance. Separate the ground wires, bare, from others. Bend and push the ground wires towards the back of the junction box. Twist the ground wires. Hold them in your fist. This gives you a minimum length of 6 inches from the box entrance, required, and cut the shorter wire at the front of your fist, leaving the longer one for pigtail wire. Thread the long wire through the hole in the green wire nut and twist it clockwise. Neatly fold and insert the ground wire connection into the junction box, leaving the pigtail wire outside the junction box. Trim the remaining wires to no shorter than 6 inches as required by the NEC, fold them and insert them into the junction box. Splicing the single pole switch junction box with the cable from the power source and the cable to the light outlet, 2 cables. Cable from the power source. Cable to the light outlet. 2 cable single pole switch junction box. Cable from the power source. Cable to the light outlet. NM cable must always be secured to the building structure within 12 inches of the cable entry into the junction box per 2023 NEC Article 334.30, but when the junction box does not have cable clamps, the cable must be secured within 8 inches of the cable entry into the junction box per the exception specified in Article 314.17, 2023 NEC. All junction boxes for switches installed in bathrooms, hallways, stairwells, and other habitable rooms or may become occupied must have a grounded, neutral conductor as defined in Article 404.2 c of the 2023 NEC. In addition, the NM cable sheath must extend no less than 1/4 inch beyond the junction box entry or cable clamp. Sketch of the wire splicing connection inside the junction box. When removing the cable sheath, leave at least 1/4 inch cable sheath length beyond the cable entry as required by NEC. Splice the ground wires using a wire nut, as the grounding conductors, wires, must always be connected together to provide effective ground fault path for current as per Article 250.148 2023 NEC. Splice the neutral wires of both cables. Trim all wires to 6 inches or longer, as wires must be at least 6 inches long from the point where they exit the cable sheath, and must also extend at least 3 inches beyond the junction box opening if the opening is 8 inches or less in any dimension, per Article 300.14 2023 NEC. Spliced, connected, wires inside the junction box. Remove the cable sheath. The cable sheath should extend no less than 1/4 inch beyond the enclosure, junction box, entrance. Separate the ground wires, bare, from others. Bend and push the ground wires towards the back of the junction box. Twist the ground wires. Hold them in your fist. This gives you a minimum length of 6 inches from the box entrance, required, and cut the shorter wire at the front of your fist, leaving the longer one for pigtail wire. Thread the long wire through the hole in the green wire nut and twist it clockwise. Neatly fold and insert the ground wire connection into the junction box, leaving the pigtail wire outside the junction box. Trim all wires to no shorter than 6 inches as required by the NEC. Strip the ends of the neutral, white, wires about 1/2 inch. Splice the neutral, white, wires by twisting them clockwise with pliers and a wire nut, then insert the spliced wires into the junction box. Fold the remaining wires and insert them into the box. Installation and connection of recessed lights with and without housings. As recessed lighting, the recessed light with housing, can or canless can be installed. Recessed light fixtures. Recessed light housing for installation in new construction when the ceiling is open. Recessed light housing for remodel installation when the ceiling is not open. Canless recessed light fixture for new and remodeled installations. Recessed lighting housing, new construction, must be installed during rough-in wiring. When installing a recessed light remodel housing, old work, or installing a canless recessed light fixture, the ceiling must be pre-wired during rough-in wiring, or wires must be installed, fished, snaked, when the ceiling is finished. Installation of recessed light fixtures with housing, can. Most popular recessed light housings are IC type, insulation contact as per Article 410.116 A2 of 2023 NEC, housings with a housing can diameter of 6 inches or 4 inches. Various finished trims, lamps, are available. Recessed light housing secured to the beam. Recessed lighting housings feature a hanger bar with pre-installed nails that can be easily attached to wooden beams. The housing can be easily moved to the desired position along the hanger bar, and this position can be locked with the locking screw. Locking screw of the housing position. The recessed light housing junction box accepts NM cables as well as metal sheathed cables. Lamp can in the housing frame. The lamp can of the housing frame can be adjusted vertically to match the wall finish. For narrow, non-standard beam spacing, the hanger bar can be cut to fit the housing between the beams. Markings on the hanging bar allow for easy cutting if necessary. The stop holds the housing at the correct height between the ceiling beams and also allows the housing to be mounted to the bottom of the beam. Cutout enabling mounting of the housing to the suspended ceiling grid. To install the recessed light housing. If the distance between the beams are smaller than the length of the hanger bar, cut the hanger bar to the desired length so that the housing can be installed between the beams. Place the hanger bar stop against the bottom of the ceiling joist where the light will be installed, and drive the pre-installed mounting nails into the beam. Slide the light housing along the hanger bar to the desired position, and lock it by tightening the screw that locks the housing in place. Cable knockouts for NM cables only with the spring clamps. Cable knockouts, round, suitable for all types of cables and conduits. Junction box wires. Bare or green, ground wire. White, neutral wire. Black, hot wire. Push-in quick wire connectors. To connect the recessed light fixture housing, open the selected cable knockout suitable for the connection. Remove 6 inches of the sheath from the end of the cable, as the Article 300.14 of 2023 NEC require at least 6 inches of free conductor in the junction box. And strip the insulation from the wire ends about 1/2 inch. Insert the cable into the cable knockout. The cable sheath must extend at least 1/4 inch into the junction box behind the cable clamp as per Article 314.17 and Article 334.19 of the 2023 NEC. Secure the cable to the building structure within 12 inches of the cable entry into the junction box as per 2023 NEC Article 334.30. The same article states that the cable length between the entry and the last support cannot be more than 18 inches. Connect the ground wire, bare or green, from the junction box to the ground wire, bare, from the cable and insert this connection into the junction box. Connect the neutral wire, white, from the junction box to the neutral wire, white, from the cable and insert this connection into the junction box. Connect the hot wire, black, from the junction box to the hot wire, black, from the cable and insert this connection into the junction box. Spliced wires inside the junction box. When using the cable knockouts other than knockouts for NM cables only, the cable must be inserted through the listed cable connector. Do not insert cable through the opening without an approved cable connector, as this is a violation of 2023 NEC Articles 314.17, 300.4 and 250.97. Never cut off the grounding conductor as not needed, but always connect it, as all exposed conductive surfaces of the lighting fixture must be connected to the equipment grounding conductor in accordance with Article 410.42, Article 250.4, AA, and Article 250.148 of the 2023 NEC. Installation of recessed light fixtures with housing, can. Splicing the light fixture housing with two cables. All light fixture housings with two cables are spliced in the same way. Cable from the switch or other light outlet, light fixture. Cable to the other light outlet, light fixture. Two cable recessed light fixture housing junction box. Cable from the switch or other light outlet, light fixture. Cable to the other light outlet, light fixture. NM cable sheath must extend no less than 1/4 inch beyond the junction box entry or cable clamp. Sketch of the wire splicing, connection, inside the junction box. When removing the cable sheath, leave at least 1/4 inch cable sheath length beyond the cable entry as required by NEC. Splice all ground wires using a wire nut, as the grounding conductors, wires, must always be connected together to provide effective ground fault path for current as per Article 250.148 2023 NEC. Splice the neutral wires, white, of both cables and the light fixture. Splice the hot wires, black, of both cables and the light fixture. Trim all wires to 6 inches or longer, as wires must be at least 6 inches long from the point where they exit the cable sheath, and must also extend at least 3 inches beyond the junction box opening if the opening is 8 inches or less in any dimension, per Article 300.14 2023 NEC. Spliced, connected, wires inside the recessed light fixture housing junction box. Stripped cables jacket about 6 inches and strip ends of wires about 1/2 inch. Open the junction box and junction box rectangular knockouts for NM cables. Insert cables into opened knockouts. Connect ground, bare wires from the cables to quick connector of green, ground wire from light fixture. Connect neutral, white wires from the cables to quick connector of the white wire, neutral, from light fixture. Connect hot, black wires from the cables to quick connector of the black, hot wire from the light fixture. Close junction box cover. Slide fixture to desired location and tight the screw to lock position of the housing. Splicing the light fixture housing with one cable. Cable from the other light fixture, or switch if one recessed light fixture will be installed. The connection is similar to the connection with two cables, only one cable will be connected. Sketch of the wire splicing, connection, inside the junction box. Spliced, connected, wires inside the recessed light fixture housing junction box. Nail the light housing to the beams with center on the light can. This is IC, insulated contact, rated housing and can be covered by insulation but need clearance above light can so it not touching any subfloor above. If space between beams is too narrow, trim hanger bars. Install the cable from the switch. Secure the cable to the beam no more than 12 inches from the housing. Strip off the cable cover for about 6 inches and strip off the ends of the wires for about 1/2 inch. Open the junction box and junction box rectangular knockout for NM cables. Insert the cable into the open knockout. Connect the ground wire, bare, from the cable to the green, ground wire of the light fixture. Connect the hot, black wire from the cable to the black, hot wire of the light fixture. Connect the neutral, white wire from the cable to the white, neutral wire of the light fixture. Close the cover of the light fixture junction box and set the light fixture in the desired location. Installation of electrical devices. Once the necessary inspections have been done where required and the walls have been finished, the electrical devices can be installed. Installation of the duplex receptacles. There are two types of duplex receptacles used: traditional and decora. Both receptacles are made the same way, they only differ in the front face look. All receptacles installed in residential buildings must be tamper-resistant, TR, type, as per Article 406.12(1) of the 2023 NEC. Tamper-resistant duplex receptacle. Article 406.12(1) of the 2023 NEC, National Electrical Code, states that all 15 and 20 amps, 125 and 250 volts non-locking type receptacles installed in all dwelling unit must be listed tamper-resistant type. Duplex receptacle, front view. Yoke. Ground terminal, green screw. Neutral terminal, silver screws. Hot terminal, gold screws. Ground slot for grounding pin of the plug. Neutral slot for neutral blade of the plug, larger, wider on the left side of the receptacle. Hot slot for hot blade of the plug, smaller, narrower on the right side of the receptacle. The neutral and hot slots are covered by a shutter of the safety, tamper-resistant, mechanism inside the receptacle. But the grounding pin slot is not. The TR mark indicates a tamper-resistant receptacle. Rating of the receptacle and its certification listing label. Screws securing the receptacle to the junction box. Threaded hole for mounting the receptacle wall plate. Cuttable receptacle yoke ears supporting the device on the wall that can be removed if necessary for certain installation. A duplex receptacle consists of two receptacles on one yoke which bonds the grounding terminals, and the current carrying terminals are connected by removable tabs between the terminals. Rear view of the duplex receptacle. Ground terminal, green screw. Neutral terminal, silver screws. Hot terminal, gold screws. Push-in, neutral and hot terminals that accept only 14-gauge solid copper conductors in a 15 amps branch circuit as specified in the device description. Push to release tabs to remove inserted wire. Side view of the receptacle with ground and neutral terminals. Side view of the receptacle with hot terminal. The duplex receptacle consists of two glued parts and is not repairable. Front part and rear part. View of the inside of the receptacle after opening. Front part has safety, tamper-resistant mechanism inside its base. The rear part contains female hot contacts with connection terminals and a yoke. with a female ground contacts, with a ground terminal, tabs at the base of the front of the receptacle that fit over tabs at the base of the rear of the receptacle to make the two parts easily fit together and hold the two parts firmly together when glued together. The tabs that must be removed when separating a duplex receptacle into two separate single receptacles. When the tabs are removed, two separate, single receptacles are created. Connection terminal with the tab. And after its removal, female hot contact removed from its base. Female contact that firmly holds the plug blade. One of the push-in spring connection terminal that is not recommended for connecting wires as it provides a poor connection that can cause overheating and damage to the receptacle, or even a fire. Tamper-resistant receptacle shutter mechanism inserted into the front part of the receptacle. Shutter mechanism removed from the receptacle front base. Interior view of the receptacle shutter mechanism. Shutter and the shutter body. The rounded corner of the shutter, the side that contacts the shutter body spring. Closer view of the shutter body. A spring that forces the shutter to close the slots of the receptacle after the plug is removed. Niche for the shutter balance cone. Two pairs of pins, one of which holds the shutter in the shutter body and the other holds the shutter mechanism in the front base of the receptacle. The tab holds and stabilizes the shutter mechanism from the side in the front base of the receptacle. View of the inside of the shutter. A cone that fits into the recess of the shutter base. Flat side of the shutter that fits into the recess in the front base of the receptacle. A conical slot that fits into the conical post in the inner front base of the receptacle. A shutter balance cone that slides into a recess in the shutter base. When the shutter is pressed down evenly during plug insertion, the part of the shutter that covers the slot of hot female contact inside the receptacle before the shutter is pressed, and the other side of the same shutter that covers the hot slot in the front base of the receptacle from which the shutter will be pressed. The edge of the shutter that holds the shutter in place at the base of the shutter. When the spring presses the shutter to the side, the flat part of the shutter that covers the hot slot in the front base of the receptacle, preventing contact with the hot female contact inside the receptacle. When trying to insert an object into the receptacle slot, the flat part of the shutter that covers the neutral slot in the front base of the receptacle, preventing contact with the neutral female contact inside the receptacle. When trying to insert an object into the receptacle slot, the shutter is stopped by the edge of the shutter base as the spring presses against the shutter, and the pins hold the shutter inside the shutter base. Conical side of the slot in the shutter that slides over the conical post in the front base of the receptacle when the shutter is balanced and pressed evenly. The other, flat side of the conical slot in the shutter that holds the shutter in place on the flat side of the conical post in the front base of the receptacle. When the spring is released and the shutter returns to its previous position. The front pair of pins that holds the shutter body in the front receptacle base, and the tab that holds and stabilizes the shutter mechanism. from the side in the front base of the receptacle. Shutter mechanism. Removed from front the receptacle base. And shutter. Removed from shutter base. The flat surface of the shutter fits into a recess in the base of the front receptacle and covers both receptacle slots, preventing any object from being inserted into these slots. The grounding slot in the receptacle is always open. How the shutter mechanism works in a tamper-resistant receptacle. Attempting to insert a thin object into only one of the receptacle slots causes the shutter mechanism to block entry because the shutter slider is unbalanced, preventing it from being moved inwards and to the side to expose the slots and allow the male blades of the plug to be inserted into the female contacts of the receptacle. When inserting a thin object into only one slot of the receptacle, pressure is exerted on one side of the shutter, causing the other side of the shutter to deflect toward the front of the receptacle in the receptacle base recess. This unbalances the shutter balance mechanism, causing the shutter to remain in the same position, blocking the opening of the receptacle slot. When into both slots of the receptacle is inserted object, plug, which presses equal and simultaneously on the shutter, balancing it. The shutter slides at the same time into the receptacle and to the side, which causes the object, male blades of the plug, to slide into the receptacle slots and engage with the female contacts inside the receptacle. One more time. When inserting the plug blades into the receptacle slots, their ends press evenly and simultaneously on the shutter. The shutter mechanism becomes balanced, and with continued pressure on the plug, the shutter cone begins to slide into the shutter cone recess in the shutter base, at the same time as the shutter cone slides into its recess in the shutter base. The conical side of the shutter slot slides off the conical post in the front base of the receptacle, while the blades of the plug, which pressing the shutter, move it inwards. The conical shapes of the shutter balance mechanism cause it to move the shutter slides not only inwards, but also to the side, as the plug presses against the shutter and moves it in and to the side. The ends of the plug's blades slide across the flat surface of the shutter until the shutter moves enough to open the slots. Opening the slots causes the plug blades to drop into the slots and engage with the female contacts inside the receptacle. When the plug is removed from the receptacle slots, the spring that constantly presses the shutter moves it back to its previous position, which causes the slots of the receptacle to be covered again. Uneven and non-simultaneous hard pressure on the slots of the receptacle will unbalance the shutter mechanism, preventing the plug from being inserted and consequently damaging the receptacle tamper-resistant mechanism. The terminals of the receptacles are usually rated for only one wire under one screw. Push-in terminals which accept 14-gauge solid copper conductors, wires, only. It is not recommended to use push-in connections for receptacles, especially those with high current draw, due to poor connection which may cause damage to the device, overheating, burning or even fire. The tabs that must be removed when separating a duplex receptacle into two separate single receptacles. A properly spliced junction box for a receptacle should have 3 or 5 wires that will be connected to the receptacle. If a receptacle is connected to a branch circuit supplying more than 2 receptacle outlets, the receptacle cannot be rated less than specified in Table 210.21b3 of the 2023 NEC, which states that for a 15 amps branch circuit, the receptacle must be rated at 15 amps. Rating of the receptacle. A duplex receptacle is considered 2 receptacles as defined in Article 100 of the 2023 NEC. Per Article 406.4a, 2023 NEC, all receptacles installed on 15 or 20 amps branch circuits must be grounding-type receptacles. The grounding-type receptacle must be connected to the equipment grounding conductor of the branch circuit in accordance with Article 250.146 of the 2023 NEC. Receptacles should be mounted using the hardware provided with the device or machine screws with a 32 threads per inch. Do not use drywall screws, as per Article 406.5 2023 NEC. Do not connect more than 2 wires to the hot or neutral terminal of the receptacle. Instead, properly splice the wires in the junction box before connecting them to the receptacle. Wires should be tightened to a torque of 14 to 18 inch-pounds for standard electrical devices unless otherwise noted by the manufacturer on the device or in its installation instructions. Without using a torque screwdriver, the wire under the electrical device screw should be tightened firmly, but not too tight so as not to damage the wire and the threads of the screw or nut. Never connect more than 1 ground wire to a single ground screw unless it is rated for multiple wires, as this creates a poor connection and does not provide a reliable ground fault current path. Instead, splice all ground wires together and connect only 1 wire under the ground screw. It is acceptable to wrap the ground wire around the ground screw to pass the ground wire to another device in a daisy chain connection. Use the screw terminals of the receptacle instead of push-in terminals. Using push-in terminals of the receptacle, especially at maximum current flow and continuous load, does not guarantee a good connection, which may cause the receptacle to overheat and, consequently, damage or even fire. Always connect the wires clockwise, not counterclockwise, because connecting clockwise pulls the wire in and secures it, while connecting counterclockwise pushes the wire out, which degrades the quality of the connection and makes it poor. When attaching the receptacle to the junction box, pay attention to the gap between the upper edge of the junction box and the surface of the installed drywall. The gap between the finished surfaces with non-combustible material and the top of the installed junction box must not exceed 1/4 inch according to Article 314.20 of the 2023 NEC. Where surfaces are finished with combustible material, extensions should always be installed to extend the junction boxes to such surfaces. Junction box extender, adjustable depth, with mounting screws. If the gap between the drywall surface and the top of the installed junction box is 1/4 inch or more, a junction box extension must be installed, per Article 314.20 and 314.22 of 2023 NEC. If the gap between non-combustible surfaces around junction box is greater than 1/8 inch, the surface must be repaired in accordance with 2023 NEC Article 314.21. The receptacle yoke, frame, must rest on the finished surface and be firmly held at this surface as per Article 406.5, A, 2023 NEC. If the receptacle yoke, frame, cannot be firmly held at the finished surface, too large gap between the finished surface and the junction box, a spacer must be used between the receptacle yoke and the front of the junction box to firmly secure the receptacle to the junction box. Electrical outlet spacer. An spacer made of a wire nut. The spacer is installed between the receptacle yoke and the front of the junction box, so that the bottom surface of the yoke is flush with the finished wall surface. The spacer is installed under the receptacle yoke. If it is necessary to install an adjustable junction box extension, a spacer, if needed, should be placed under the extension, between the extension and the front of the junction box. A receptacle wall plate that covers the receptacle opening and is flush with the finished surface must be installed in accordance with 2023 NEC Article 406.6. Installation of a duplex receptacle in junction boxes with 5 wires that will be connected to the receptacle after splicing. Sketch of the junction box with 5 wires that will be connected to the receptacle. Sketch of a connected duplex receptacle. The junction box with 5 wires that will be connected to the receptacle. Make a loop at the end of each wire. Ground wire. Neutral wires. Hot wires. Connect the ground wire, bare, to the ground terminal, green screw, of the receptacle. Connect the neutral wires, white, to the neutral terminal, silver screws, of the receptacle. Connect the hot wires, black, to the hot terminal, gold screws, of the receptacle. Secure the receptacle to the junction box and install the receptacle wall plate. Pull the spliced wires out of the junction box. Strip the insulation from the ends of the wires about 1/2 inch and make loops in the ends of the wires. Connect the ground wire, bare, to the ground terminal, green screw, of the receptacle. Connect the neutral wires, white, to the neutral terminal, silver screws, of the receptacle. Connect the hot wires, black, to the hot terminal, gold screws, of the receptacle. Secure the receptacle to the junction box. Level the receptacle and install the receptacle wall plate. Installation of a single pole switch. There are two types of single pole switches used: traditional and decora. Both switches are made in the similar way. They only differ in the front face, front look. Construction of a single pole switch. Front view of a single pole switch. Handle with two marked operating positions: off and on. Yoke. Ground screw attached to the metal yoke. Rivets that hold all the main parts of the switch assembly together, visible from the front of the switch. Yoke ears that support the switch against the wall finish, which can be removed for some installations if necessary. Screws securing the switch to the junction box. Holes for screws securing the switch wall plate. Rating of the switch. Type of wires allowed to be connected to the switch. Laboratory mark that is listing the switch. Single pole switch, rear view. Terminal for the ground wire connection, green screw. Connection terminals, gold screws, for the hot wires, from the power source and to the light outlet. Rivets that hold all the main parts of the switch assembly together, visible from the back of the switch. Push-in terminals for rear wiring that accepts 14-gauge solid copper wire only. This type of wiring is not recommended as it does not provide a good connection. Release mechanism for removing wires from push-in terminals. Strip gauge for wires used for rear wiring. Side view of a single pole switch with hot terminals. Side view of a single pole switch with ground terminal. Parts of a single pole switch after cutting the rivets. Switch base with contacts and terminal screws. Top cover of the switch base with the switch handle. Yoke. Inside view of the switch base. And switch cover separated after the rivets were broken. Switch base with contacts and terminal screws for connecting the wires. One of the screw terminals, gold screw, for the hot wire. With spring contact. Second screw terminal, gold screw, for the another hot wire. With fixed contact. A spring holding the handle cone allows the handle to be easily moved from one position to another and keep it in that position. Stoppers that hold the handle in the desired position after switching. Inside view of the switch cover with the switch handle. The handle is inserted into the slot in the switch front cover and hinged in the handle hinge slot in the switch front cover. The cone of a switch handle that is inserted into the spring inside the switch. A switch handle arm that depresses the switch spring contact when the switch handle is in one of the two positions. Stopper on the switch handle, which stop the handle when it touches the switch base stopper, keeping the handle in the right position. A closer look at the switch handle. Switch handle hinges, which fit into the switch cover hinge slots. The switch handle cone that engages the spring in the switch base. The arms of a switch handle that depress on the spring contacts in the switch base. For better understanding, a sketch of a single pole switch contacts will be presented. Sketch of the single pole switch contacts. And a photo of the switch base with contacts. Switch contacts shown in a sketch. One of the hot terminals with spring contact. Second hot terminal with fixed contact. How does a switch work, creating a path for current and allowing it to flow? Sketch of a single pole switch controlling a light outlet. When the switch handle is in off position, the arm of the switch presses the spring contact so that this contact does not touch the fixed contact. The current path is open between the terminals of the switch, and the current does not flow. When the switch handle is moved to the other on position, the handle arm releases the previously pressed spring contact, and now that spring contact naturally touches the fixed contact of the switch. The current path is closed between the terminals of the switch and current flows from the power source through the switch closed contact to the light outlet and returns to the source through the neutral wire. The terminals of the switches are usually rated for only one wire under one screw. Push-in terminals which accept 14-gauge solid copper conductors, wires, only. It is not recommended to use push-in connections, especially with high current draw, due to poor connection which may cause damage to the device, overheating, burning or even fire. A properly spliced junction box for a single pole switch should have 3 wires that will be connected to the switch. Switches must be used in accordance with their ratings as specified in Article 404.14 of the NEC 2023. Switches should be mounted using the hardware provided with the device or machine screws with a 32 threads per inch. Do not use drywall screws, as per Article 404.10, b. 2023 NEC. Neutral wire is required at the switch location specified in Article 404.2, c. of 2023 NEC. All metal parts of the switches, yoke, metal faceplate, must be connected to the equipment grounding conductor as per Article 404.9, b. 2023 NEC. Do not connect more than one wire to the hot terminals, gold screws, of the switch unless is rated for more wires. Instead, properly splice the wires in the junction box before connecting them to the switch. Wires should be tightened to a torque of 14 to 18 inch-pounds for standard electrical devices unless otherwise noted by the manufacturer on the device or in its installation instructions. Without using a torque screwdriver, the wire under the electrical device screw should be tightened firmly, but not too tight so as not to damage the wire and the threads of the screw or nut. Always connect the wires clockwise, not counterclockwise, because connecting clockwise pulls the wire in and secures it, while connecting counterclockwise pushes the wire out, which degrades the quality of the connection and makes it poor. Never connect more than one ground wire to a single ground screw unless it is rated for multiple wires, as this creates a poor connection and does not provide a reliable ground fault current path. Instead, splice all ground wires together and connect only one wire under the ground screw. It is acceptable to wrap the ground wire around the ground screw to pass the ground wire to another device in a daisy chain connection. When attaching the switch to the junction box, pay attention to the gap between the upper edge of the junction box and the surface of the installed drywall. The gap between the surface of the finished wall and the top of the installed junction box must not exceed 1/4 inch according to Article 314.20 of the 2023 NEC. Junction box extender, adjustable depth, with mounting screws. If the gap between the finished surfaces with non-combustible material and the top of the installed junction box is 1/4 inch or more, a junction box extension must be installed, per Article 314.20 and Article 314.22 of 2023 NEC. Where surfaces are finished with combustible material, extensions should always be installed to extend the junction boxes to such surfaces. If the gap between non-combustible surfaces around junction box is greater than 1/8 inch, the surface must be repaired in accordance with 2023 NEC Article 314.21. The switch yoke, frame, must rest on the finished surface and be firmly held at this surface as per Article 404.10, b. 2023 NEC. If the switch yoke, frame, cannot be firmly held at the finished surface, too large gap between the finished surface and the junction box, a spacer must be used between the receptacle yoke and the front of the junction box to firmly secure the switch to the junction box. Electrical outlet spacer and spacer made of wire nut. The spacer is installed between the switch yoke and the front of the junction box, so that the bottom surface of the yoke is flush with the finished wall surface. The spacer is installed under the switch yoke. If it is necessary to install an adjustable junction box extension, a spacer, if needed, should be placed under the extension, between the extension and the front of the junction box. All switches must have switch wall plates that covers switch opening and are flush with the finished surface as per Article 404.9, a. 2023 NEC. Installation of a single pole switch in junction box with wires that will be connected to the switch after splicing. Sketch of the switch junction box with wires that will be connected to the single pole switch. Sketch of a connected single pole switch. To connect the single pole switch to the wires from the junction box. The junction box of a single pole switch has 3 wires that will be connected to the switch. Ground wire. Hot wire from the cable from the power source. Hot wire from the cable to the light outlet. Connect the ground wire, bare, to the ground terminal, green screw, of the switch. Connect the hot wires, black, to the hot terminals, gold screws, of the switch in any order. Pull the spliced wires out of the junction box. Strip the insulation from the ends of the wires about 1/2 inch and make loops in the end of the ground wire. If required by the NEC, install a box extender. Connect the ground wire, bare, to the ground terminal, green screw, of the switch. Connect the 2 hot wires, black, to the hot terminals of the switch in any order. Secure the switch to the junction box and level it. Install the switch wall plate. Installation of the recessed light housing trims. Recessed remodeled housing with trims or canless light fixture. When installing a recessed lighting fixture with housing, if the gap between the finished surfaces with non-combustible material and the top of the installed junction box, recessed light fixture is treated as a junction box because it contains wires, is 1/4 inch or more. A light housing lamp must be adjusted as per Article 314.20 and Article 314.22 of 2023 NEC. Where surfaces are finished with combustible material, the lamp can of the light housing frame must always be adjusted to extend the lamp can edge to be flush with such surfaces. If the gap between non-combustible surfaces around recessed light is greater than 1/8 inch, the surface must be repaired in accordance with 2023 NEC Article 314.21. If necessary, clean the spackle around the recessed light housing. Unscrew the screws securing the lamp to the housing and adjust it so that its edge is flush with the ceiling surface. To adjust the socket plate, loosen its screw, push socket plate all of the way up and tighten the screw. Install the light trim and the light bulb or retrofit trim listed for this type of recessed light fixture housing. Screw the lamp bulb socket plug into the light bulb socket in the housing. Compress the springs and insert into the ears on the inside of the recessed housing can. Push trim into the housing until the trim is flush with the ceiling surface. To complete the installation of canless lighting fixtures after the drywall installation, mark on the plan the distances from the walls where the light cable is placed, or take photos of the cable locations to make it easier to determine the cable locations when installing the recessed light fixtures. After installing drywall or other wall finishing, mark the mounting locations for recessed lights near the locations of the cables left behind the drywall. And cut a hole of the diameter specified in the installation instruction for the type of the light fixture to be installed. Pull the cable or cables out from behind the ceiling finish, usually drywall, and install the light fixture junction box. To install a cable or cables into the light fixture junction box, cut the cable or cables to a length that will allow you to easily work outside the opening in the ceiling for the light fixture lamp when connecting the cables to the light fixture junction box. Remove 6 inches of the sheath from the end of the cable, as the Article 300.14 of 2023 NEC require at least 6 inches of free conductor in the junction box. And strip the insulation from the wire ends about 1/2 inch. Canless light fixture junction box and its lamp. Make sure the junction box will accommodate the wires to be connected. Typically this is no more than wires from 214. 2 cables. Light fixture junction box wires. Green, or bare, ground wire. White, neutral wire. Black, hot wire. Install approved cable connector to the junction box. And insert the cable into the cable connector. The cable sheath must extend at least 1/4 inch into the junction box behind the cable clamp as per Article 314.17 and Article 334.19 of the 2023 NEC. Another way is to install the cable connector on the cable, and then install the cable connector with the cable in the junction box of the light fixture. Connect the ground wire, bare or green, from the junction box to the ground wire, bare, from the cable and insert this connection into the junction box. Connect the hot wire, black, from the junction box to the hot wire, black, from the cable and insert this connection into the junction box. Connect the neutral wire, white, from the junction box to the neutral wire, white, from the cable and insert this connection into the junction box. Insert connected wires into the junction box. And close the junction box cover. Article 334.30 of the 2023 NEC states that the cable must be supported within 12 inches of the junction box entry, and the cable length between the cable entry and the last support cannot exceed 18 inches. Therefore, when the cable was supported at the intended light outlet location during installation, it should meet within 12 inches support requirement from the cable entry into the junction box and the maximum 18 inches cable length requirement from the last support to the cable entry into the junction box, because the cable that was left was 24 inches or longer, up to 4.5 feet. Unsupported NM cable can be longer if meets Article 334.30b of the 2023 NEC. Insert the junction box into the opening and place it on the drywall as per instructions. The junction box of the luminaire, light fixture, is an integral part of the luminaire in accordance with the manufacturer and Article 410.118 2023 NEC. Therefore access to it is possible after removing the lamp, which is not allowed for other junction boxes. Connect the light fixture lamp to the junction box and install the lamp in the ceiling according to the instructions. For all canless recessed lights, installed after the ceiling has been finished, drywall installed, refer to the instructions for installing lights during renovation. Mark light location, cable already installed during rough-in wiring before sheetrock installation. Drill a hole for the light fixture using drill cutter appropriate for the size of the canless recessed light lamp and start drilling counterclockwise, otherwise sheetrock damage possible. The hole can also be cut using a sheetrock saw. Template may not be supplied. Pull the cables, already installed, out from behind the drywall. Trim the cables if they are too long. Insert the cables into an approved cable connector. Cables must be at least 6 inches long from the connector end to the end of the cable. Strip the cable's sheath. For easier connection, disconnect recessed light lamp from the junction box. Open the junction box cover and open the junction box cable knockout. Insert the connector with cables into the junction box knockout. Insert a push-in wire connector, supplied with the light, onto the end of each wire coming from the recessed light junction box. Trim cable wires, if more than 6 inches, and strip the ends of the wires about 1/2 inch. Insert ground cable wires, bare, into push-in ground wire, green cable connector from the junction box and insert connected wires into the junction box. Insert neutral cable wires, white, into push-in neutral wire. white cable connector from the junction box and insert connected wires into the junction box. Insert hot cable wires, black, into push-in hot wire, black cable connector from the junction box and insert connected wires into the junction box. Close junction box cover and select desired lamp color temperature using the switch on the junction box. Insert junction box into the opening for the light fixture lamp. If the recessed light lamp was disconnected, reconnect it to the junction box. Rest one torsion spring against the drywall in the ceiling opening. Tilt the other torsion spring and insert the light fixture lamp into the ceiling. To remove the installed fixture, gently pull the fixture down to reach the torsion springs. Tilt the springs and take out the fixture. Power supply to the room. Power to the room may come directly from the panel board, most common, or may be taken from another junction box supplying power to other rooms, depending on the required load. The power supply to this room comes directly from the panel board. For this branch circuit AFCI, arc fault circuit interrupter, protection must be installed as per Article 210.12 of the 2023 NEC. Per 2023 NEC Article 210.24, the overcurrent protection required for 14-gauge copper wire, 2 nm cable conductors, is 15 amps. A 15 amps AFCI circuit breaker shall be installed on the branch circuit to provide protection for the entire branch circuit from the panel board, as required by Article 210.24 and Article 210.12, A.1 of the 2023 NEC. Always check the circuit breaker rating on its label to ensure that the correct circuit breaker will be installed to protect the branch circuit. The circuit breaker must be listed and rated for the panel board in which it will be installed as per Article 110.3 and Article 408.6 of the 2023 NEC. Two types of AFCI circuit breakers are available. A circuit breaker plug-on neutral type for the latest panel boards with a plug-on neutral design, and a circuit breaker with a pigtail wire for connection to the panel board neutral bus bar for all panel boards, with or without plug-on neutral bar, that accepts the circuit breaker. Dual-purpose AFCI, GFCI, arc fault circuit interrupter, ground fault circuit interrupter, circuit breakers are also available in both versions. AFCI and GFCI circuit breakers can be installed wherever they are not required by the NEC, as this improves electrical safety. The NEC only specifies minimum requirements for electrical installations but does not prohibit increased safety, and therefore, where only AFCI protection is required, the addition of GFCI protection when installing a dual-purpose circuit breaker is highly encouraged and does not violate NEC standards. AFCI, arc fault circuit interrupter, circuit breaker with pigtail wire details. Handle, on, off, with description of the circuit breaker overcurrent protection rating, 15 amps. Test button. Neutral wire terminal, white dot mark. Hot wire terminal. Pigtail wire. Plug-in, jaw, line terminal of the circuit breaker for connection to the panel board line busbar. Plug-on neutral, PON, circuit breaker details. Handle, on, off, with description of the circuit breaker overcurrent protection rating, 20 amps. Test button with circuit breaker status indicator, cause of tripping. Neutral wire terminal, white dot mark. Hot wire terminal. Plug-on neutral circuit breaker connection jaw for connection to the neutral bar of the panel board. Plug-in, jaw, line terminal of the circuit breaker for connection to the panel board line bus bar. Panel board with the main circuit breaker, service disconnect. And plug-on neutral bars. Ground neutral bar is common for the ground and neutral wires, and is bonded to the enclosure. The ground and neutral wires are connected to the same ground neutral bar. Hot, power, bus bars. Panel board without main circuit breaker, main lugs, and plug-on neutral bars. The ground bar is separated from the neutral bar, which is not bonded to the enclosure. The ground and neutral wires must be separated and connected appropriately. Neutral wire to the neutral bar and ground wire to the ground bar, as per Article 250.142, B, 2023 NEC. Panel boards with plug-on neutral bars support both types of circuit breakers, plug-on and with pigtail wire. Panel boards without plug-on neutral bars support only circuit breakers with pigtail wire. Only one neutral conductor can be terminated under same screw as per Article 408.41 2023 NEC. Multiple ground wires, equipment grounding conductors, can be connected under the single screw of the terminal in the panel board, as specified on the panel board label. When tightening the screws, use the appropriate torque specified on the panel board label. Circuit breakers must be listed for use in the panel board in which they will be installed. Check the panel board label to install the circuit breaker which has a pigtail wire. Insert the circuit breaker into the breaker slot in the panel board and connect as follows. Circuit breaker pigtail wire to the neutral bar in subpanels, or ground neutral bar in the main electrical panel. Ground wire, bare, from the cable to the ground bar in subpanels, or ground neutral bar in the main electrical panel. Neutral wire, white, from the cable to the neutral terminal of the circuit breaker. Hot wire, black, from the cable to the hot terminal of the circuit breaker. Turn off the main breaker or the feeder breaker for the subpanel. Remove the panel cover. Open the selected knockout in the panel board enclosure. Insert the cable connector into the open knockout. Insert the cable into the connector and fasten the cable, usually a staple, 12 inches from the panel board. Strip the cable jacket. Route the ground wire, bare copper conductor, neatly inside the load center panel board and connect it to the neutral ground bar in the panel. Install the AFCI circuit breaker. Connect, terminate, the pigtail wire from the circuit breaker to the neutral ground bus. Route the neutral, white, wire, conductor, inside the panel board, trim it, strip the end of the wire about 1/2 inch and connect it to the neutral terminal screw of the circuit breaker. Route the hot, black, wire, conductor, inside the panel board, trim it, strip the end of the wire about 1/2 inch and connect it to the hot terminal screw of the circuit breaker. Power up the panel and test the circuit breaker with the connected circuit for proper operation. Remove the knockout and panel board cover for the installed circuit breaker. Reinstall the panel board cover. Mark, describe the installed circuit breaker. Attach the test instruction and the test reminder label, supplied with the AFCI switch, in a visible position on the enclosure. To use a plug-on neutral circuit breaker, the panel board must be equipped with a neutral bus that accepts such breakers. To install the plug-on neutral circuit breaker, insert the plug-on neutral connection jaw of the circuit breaker onto the plug-on neutral bar located in the panel board, and plug the circuit breaker to the hot bus bar tabs of the panel board. Connect the ground wire, bare, from the cable, to the ground bar, in subpanels, or ground, neutral bar in the main electrical panel. Connect the neutral wire, white, from the cable, to the neutral terminal of the circuit breaker. Connect the hot wire, black, from the cable, to the hot terminal of the circuit breaker. Turn on the circuit breaker powering the branch circuit in the room and check that the receptacles and lighting are working properly. Another option for powering this room is to draw power from a junction box of a circuit powering another part of the house. The circuit from which the electricity will be drawn must have sufficient ampacity to also power the room or part of it to be wired. The circuit extension for supplying the described room or part of such room shall not be taken from circuits specifically designated for specific areas of the house, such as a kitchen countertop receptacles, a bathroom receptacles, etc. For any circuit extension in an area of the house where AFCI protection is required, AFCI protection for that extension must be provided in accordance with Article 210.12(e) of the 2023 NEC. AFCI duplex receptacle, which can provide AFCI protection for circuit extension where it is required. AFCI protection for a circuit extension can be achieved by replacing the existing standard circuit breaker protecting that circuit with a combination type AFCI circuit breaker, or by installing an AFCI receptacle in the first receptacle outlet of the existing circuit as per Article 210.12(e)(2) of the 2023 NEC. If a circuit extension cable is taken from a receptacle outlet located in another room or place, the receptacle from which the cable is taken should be replaced with an AFCI receptacle that will protect the entire extended circuit. If the circuit extension is taken from the switch, light outlet or other junction box where the AFCI protection for extended circuit cannot be installed, the AFCI receptacle can be installed at the first receptacle junction box of the new circuit extension, which will provide protection for the entire extension. If no receptacle outlet will be installed on the circuit extension, lighting only will be installed, and the power will be taken from a source other than the receptacle outlet. And the standard circuit breaker cannot be replaced with an AFCI breaker. The old panel board does not support such breakers. An additional junction box for the AFCI receptacle outlet as an additional outlet must be installed to provide protection for the entire circuit extension. The AFCI receptacle must be installed in an easy accessible location as per Article 210.12/2023 NEC. AFCI duplex receptacle and dual-function AFCI, GFCI, arc fault circuit interrupter, ground fault circuit interrupter, duplex receptacle, front view. All receptacles installed in residential buildings must be tamper-resistant (TR) type as per Article 406.12(1) of the 2023 NEC. AFCI or AFCI, GFCI duplex receptacle details. Yoke, frame with self-grounding spring, clip. Screws securing the receptacle to the junction box. Threaded holes for mounting the receptacle wall plate. Cuttable receptacle yoke ears supporting the device on the wall that can be removed if necessary for certain installations. Receptacle test button. Receptacle reset button. AFCI, GFCI receptacle, rear view. Ground terminal, green screw. Line, in, terminals. Load, out, terminals. Line neutral terminal, silver screw. Line hot terminal, gold screw. Load neutral terminal, silver screw. Load hot terminal, gold screw. Although some manufacturers rates AFCI receptacle terminals as being designed for 2-wire connections, it is best not to connect more than 5 wires, 1 per terminal, to such a receptacle, as the connection at the terminals may overheat during use, especially when the other outlets are feed that terminal, which may cause the connection to loosen and all the problems related with it. It is good practice to splice wires before connecting them to the receptacle, as this splicing provides a much better connection than one that relies on the receptacle terminal. A properly spliced junction box for an AFCI receptacle should have 3 wires, if the receptacle does not have a connected load side, or 5 wires, if the receptacle has a connected load side, that will be connected to the receptacle. If a receptacle is connected to a branch circuit supplying more than 2 receptacle outlets, the receptacle cannot be rated less than specified in Table 210.21 B3 of the 2023 NEC, which states that for a 15 amps branch circuit, the receptacle must be rated at 15 amps. Rating of the receptacle. A duplex receptacle is considered 2 receptacles as defined in Article 100 of the 2023 NEC. Per Article 406.4 A, 2023 NEC, all receptacles installed on 15 or 20 amps branch circuits must be grounding type receptacles. The grounding type receptacle must be connected to the equipment grounding conductor of the branch circuit in accordance with Article 250.146 of the 2023 NEC. If it is an AFCI, GFCI receptacle, it can also be installed on circuits without an equipment grounding conductor and must be marked, no equipment ground, according to Article 406.4 D2 of 2023 NEC. Receptacles should be mounted using the hardware provided with the device or machine screws with a 32 threads per inch. Do not use drywall screws, as per Article 406.5 2023 NEC. Wires should be tightened to a torque of 14 to 18 inch-pounds for standard electrical devices unless otherwise noted by the manufacturer on the device or in its installation instructions. Without using a torque screwdriver, the wire under the electrical device screw should be tightened firmly, but not too tight so as not to damage the wire and the threads of the screw or nut. If required by the NEC, a junction box extender must be installed. Connection of the AFCI receptacle to protect the circuit extension. Sketch of existing junction box with added cable that extends the branch circuit. Sketch of a connected AFCI receptacle for extended circuit protection. A properly spliced AFCI receptacle junction box that will protect the extended branch circuit should have 5 wires. Spliced ground wires which must be connected to the ground terminal of the receptacle. Spliced wires from existing circuit which must be connected to the line terminals of the receptacle. Wires from the cable extending the branch circuit that must be connected to the load terminals of the receptacle. Connect the ground wire, bare, from the junction box to the ground terminal, green screw, of the receptacle. Connect the neutral wire, white, of the existing circuit from the junction box to the line side neutral terminal, silver screw, of the receptacle. Connect the hot wire, black, of the existing circuit from the junction box to the line side hot terminal, gold screw, of the receptacle. Connect the hot wire, black, of the circuit extension cable from the junction box to the load side hot terminal, gold screw, of the receptacle. Connect the neutral wire, white, of the circuit extension cable from the junction box to the load side neutral terminal, silver screw, of the receptacle. Secure the receptacle to the junction box and install the receptacle wall plate. Turn off the power to the receptacle from which the branch circuit extension cable will be connected and unscrew the receptacle from the junction box. Install the cable. Insert it into the junction box, and secure it to the building structure in accordance with NEC requirements. Remove the cable sheath. The cable sheath must extend no less than 1/4 inch beyond the junction box entry. Disconnect all wires from the receptacle and remove the receptacle device. Splice the ground wire of the added cable to the existing, spliced ground wires. Take a white wire of the same gauge as the one in the junction box to make a pigtail wire. Splice it to the existing neutral wires, white, disconnected from the receptacle, and insert this connection into the junction box. Take a black wire of the same gauge as the one in the junction box to make a pigtail wire. Splice it to the existing hot wires, black, disconnected from the receptacle, and insert this connection into the junction box. Group all wires, bend them and push towards the back of the junction box. Grab them with the fist and cut them in front of the fist. Strip the ends of the wires about 1/2 inch. Connect the ground wire, bare, from the junction box to the ground terminal, green screw, of the receptacle. Connect the neutral wire, white, of the existing circuit from the junction box to the line side neutral terminal, silver screw, of the receptacle. Connect the hot wire, black, of the existing circuit from the junction box to the line side hot terminal, gold screw, of the receptacle. Connect the hot wire, black, of the circuit extension cable from the junction box to the load side hot terminal, gold screw, of the receptacle. Connect the neutral wire, white, of the circuit extension cable from the junction box to the load side neutral terminal, silver screw, of the receptacle. Use a screwdriver to check that the wires are not loose after connection. Secure the receptacle to the junction box, level it and install the receptacle wall plate. If this video is helpful, please subscribe. Comments are welcome.